Okay, so the seller strategy is 1800, 1200, but the buyer has how many strategies? So the buyer has 2 nodes, right?
Mm-hmm.
You can either accept or reject here, and also can either accept or reject here.
Mm-hmm.
So the buyer strategies are, so the seller will be 1800 or 1200. So the buyers will actually be something like, he'll have 4 strategies, or she'll have 4 strategies. One will be accept, so 1800 accept, 1200 accept. In other words, accept both. Another one will be accept 1800 but reject 1200. You see, it'll be up playing here, then here.
Yeah, that's okay.
Okay, so the buyer strategy is going to be a choice of what to do here and a choice of what to do here. It's like a combination. So one of those combinations is accept here and accept here. That means accept anything.
Okay, so it'd be like 1800 accept and then 1200 accept?
No, it would be, this would all be one strategy. So I'd write it this way. I would write it as 800 accept and 1200 accept, all in the same thing.
Okay.
Or you can write it like, you could like, 800, sometimes people do like this, the arrows. Or you could just do AA. This means like accept at the top and also accept at the bottom. Another one would be, so 1800 accept, 1200 reject. That means accept the 1800 but did reject the 1200.
1200 reject. How do you know how to organize these? Like 800 you go accept, and then down here.
Well, you can. There's no big deal about the order, but the main thing is just to realize there's 4 of them, right? One is accept, accept. That's this.
Because I had 4 too, but they were wrong.
Right. The reason is because this only tells you what the buyer does if he's accepted 1200. To completely specify the buyer's strategy, you also have to tell what the buyer would do if he was offered 1800. See what I'm saying? So it's like a rule book or a guidebook for the buyer. The guidebook has to include all possible contingencies. Okay, so yeah, so one way to organize it is like this. You see, kind of like you're ready, 1800 accept, 1200 accept, others 1800 accept, 1200 reject. What would another one be?
1800 reject, 1200 accept.
Yeah, exactly.
And then both reject.
Right, exactly. Okay, so then once you have these, then you can fill in the numbers. Let's see. So I guess you might have to erase these a little bit. Okay, so what would go in here?
It's 1800 and then he's accepting and 1200 reject.
Right, so this means the buyer accepts 1800 and also accepts 1200, but this part of the game doesn't get played because the seller does 1800, right? So the seller offers 1800. The buyer accepts it, and then they end up here. It's 10.5, so it's just plain old 10.5.
And you just ignore this part?
Yeah, because this tells the buyer exactly, absolutely. Okay, so what about down here?
So 1200 accepts. This one would be ignored because he's not choosing 800.
Right.
1200, he's accepting it. So it'd be 5 times.
Very good. Okay.
This one 800. Would it be 10.5 again? 1200. Zero, zero.
Very good.
Zero, zero.
Oh, can we move it here so we can get to the camera?
Okay,
I think it's working, no problem.
1200. So 5 times. 1200 reject. 0, 0. 1200 reject. 0, 0.
Okay. So, what are the? If I find Nash equilibrium of this game, what would it be?
We do both for 0.
Right.
And then with this one, we compare it across.
Oh, here, so there's 3 Nash equilibria. Okay, so which one is subgame perfect?
Subgame perfect also confuses me because you start here with the greatest payoff being the second players.
Right. Okay. So yeah, every time you do the subgame perfect thing, you look at. So here's the buyer's making the choice, right? So you look at the buyer's payoffs.
Okay, so it'd be this one.
Yeah. For example, here the buyer would go up here because 10 is bigger than 0, right? So the buyer's going to do that. Here, what would the buyer do?
5.
Yeah, so do that so you can
So we do
color
it for
it.
both subgames?
Yeah, you start with the end and look at all the subgames, and then you color the arrows. Okay, so once this arrow's colored in, this arrow's colored in like this. Okay, then what does the seller do here?
The seller, so we look at the seller's payoff as well?
Right, now, if the seller goes to 1200, in the end what will happen?
He gets 5.
Right, if the seller goes to 1800, what in the end will happen?
He gets 10.
So therefore, what did the seller do?
This
Yeah,
one.
very good. That's it.
Okay.
So the subgame perfect Nash equilibrium is the coloring of these arrows. We're saying the seller does 1800, and the buyer accepts here. So if I look in this, which is the subgame perfect Nash equilibrium in here? Yeah,
This one?
yeah, exactly. It's this one. The seller does 1800, and the buyer accepts either offer.
Okay. And we would write that as seller.
You just do 1800, yeah.
Oh, okay.
Then it would be like 1800 accept, 1200 accept, or yeah.
Okay.
Does that make sense? Okay.
So this is how we make a table
Mhm.
for anything?
Yeah, for an A tree, yeah, you would make the table this way. So this.
So you look at 1800 and then him accepting, and then combination of accept, reject, accept.
Yeah, exactly. So the remember the definition of a strategy is a complete contingent plan. What does that mean? That means that for every node which I get to play, you have to specify what I do in all of those nodes. So here, the seller is easy because the seller only has one node, so you just have to specify 1800 or 1200. Here the buyer has two nodes, you just have to specify what happens in both of those nodes. And that would be a strategy.
Okay. Oh, and if we just need to find the pure strategy,
The subgame
the
perfect, right?
subgame perfect, do we need to make a table?
No, we don't.
Okay.
You just have to do the backward induction thing.
Yeah, so I just need to go back and do my tables.
Yeah, exactly right. Yeah. So this would be like, it'd be attack, not attack. This would be obliterate if attacked, obliterate if not attacked.
Okay.
See what I'm saying? It'd be exactly the same kind of structure.
Okay.
One would be like never, right? So the strategy is will always look like attack, not attack. So I guess what if there's obliterate or nothing, right? So one would be this obliterate in either case. Another one would be obliterate if attacked, nothing, right? Another one would be do nothing if attacked, obliterate if not attacked, and the final one would be what? Oh, sorry. Do nothing, regardless. Right?
Okay, so it would be obliterate, and what is this, attack?
I guess O means obliterate.
Oh, okay, so it would be obliterate.
Oh no, hold on, are we doing the right? Am I doing the right way? There's an order, right? Number 3 is, yeah, 3 move firsts. So country A moves first, that would be attack or not attack, and then B does obliterate or not. Yeah, that would be the A part.
So it would be attack, obliterate.
Yeah, exactly, right. Yeah, that's for the A part. And the B part, you just flip it around. Yeah,
Okay.
exactly.
So you start with B and the B part.
Right.
Okay.
Yeah. Okay.
Backwards induction,
Uh-huh.
is that the same thing we've been doing to find the subgame perfect?
Yeah, absolutely. Right.
Okay, so like here,
Mm-hmm.
it would be this one?
Okay, so this is again, there's 5 stones, right? And then you win if you pick the last stone, right? So, let me see. So here 1 does 2, and then 2 takes another 2, and then 1 takes the last one, right? Is that what it is? Or is there, are there 4 stones?
I think there's just 4 stones.
Oh, let's go 5.
Oh, there's 5
Right,
stones.
okay, this is okay. This is 4 stones. That's fine. We'll do the 4 stone version.
Okay.
This is fine. Yeah. So if 1 takes 2 and 2 takes 2, then 1 wins. Sorry, 2 wins, right? 1 takes 2, 2 takes 1, then 1 takes 1. Then yeah, okay, fine. This is the wait for 4 stones. So let's do the backward induction thing. What does 1 do here?
He wins.
Yeah, there's no choice. There's one strategy there, right?
So we look at both 1's payoffs. Oh, okay, because this is 1's node.
Yeah, exactly right.
Okay.
You only look at 1's payoffs because 1 doesn't care about 2. 1 only cares about his own payoff.
So he would win here and here.
Right. Oh, how about here? What does 2 do here?
2,
Also, right?
yeah.
So if you only have one strategy, obviously you just take it. What does 1 do here? If 1 plays 2, he'll get 10, he'll win. If 1 goes here, he loses, right? So what does
So
1?
does that one.
Right. How about here?
2 does
No, 16 is bigger than 0, right?
And then we go back. We don't have payoffs here, right?
Right, because we don't have payoffs here, but what you think about it. How about here? What does 2 do here?
2 would go 1 one's here, so he would go this way.
Yeah, so if he goes this way, he gets 0, right? If he goes this way, what ends up happening?
He gets 0.
Right, so 2 actually loses either way here. So it's a tie. So let's just choose one of them maybe.
You could just choose whatever one
Right.
when it's a tie.
Right.
But wouldn't this one he could possibly win if he kept
Well,
going?
in some sense that's true, yeah. Someone said this morning, but the idea is that if 2 picks 1, then 1 will certainly pick 2. Yeah.
Okay,
Right.
yeah.
Because 1 will definitely win that way. So yeah, there's a tie here, but let's just say 2 goes here. Okay, now you're right. When 1 chooses here, 1 doesn't know the payoffs immediately. However, 1 can look at all these arrows and kind of see what will happen in the end. So when 1 chooses 2, what happens in the end?
2 will win.
Right. If 1 goes here, what happens in the end?
2 heals, 1 will win.
Right. So what is 1 going to do?
This way.
Yeah, that's it.
Okay.
So that's it. This is the second perfect Nash equilibrium.
Okay.
Yeah.
This one. I felt okay. Well, the one with the boyfriend and the cruise.
Right. Right.
The notes. See, I felt like you had to put the payoff here. I didn't know where to put it.
Oh, what you've written down is fine. So these payoffs are like the payoffs from spending time together. Yeah. And then if you break up, then you get the if you're dumped on, you lose 10, right? Yeah. So these payoffs look fine. Okay. These are not really the payoffs. This is just like a little like
work.
Yeah, like exactly like
payoff.
exactly right
Okay.
exactly. Okay, so do you want to do the SPNE? Okay, so what is the at this stage? What does the boyfriend do on Sunday?
Break up with her.
Yeah, because there's no other choice, right? Here on Saturday, what does the girlfriend do?
Break up with him.
Right, because what?
She gets 30.
In 30 instead of 25, right? Okay, how would you?
Friday, boyfriend will break up with
Yeah,
him.
because 25 is bigger than, if he continues, right, in the end he'll get 20, right, so 25 is bigger than 20.
But if he continued, couldn't he get 35?
Okay, right, that's kind of like what you said before. Sure, if I continue, then maybe I have a chance of getting 35. But the idea is, if I continue, well, the girlfriend will surely break up with me because the girlfriend doesn't want to get 25, right?
Okay.
So he can, in other words, the boyfriend anticipates what the girlfriend will do on Saturday. Okay, so he anticipates that the girlfriend will break up on Saturday, and then he'll 20, so he'll want to break up early. Okay, how about you?
The girlfriend breaks up with him.
Yeah, because 20 is bigger than 15.
So wouldn't they all break
Yeah,
up
exactly
with each
right.
other in the beginning?
Yeah, that's why this is kind of an interesting example. It ends up being the same as this. It's kind of like what you're saying. They end up, breaking up right at the beginning because no one wants to be the person on the, holding the bag in some sense, right? Since no one wants to be the person holding the bag, each person wants to dump before the other one before they get the chance to be dumped themselves. So they end up both getting payoffs which are much lower than if they had gone on a little longer.
So how would we write that? Would we choose all of these?
Yeah, so what is the SPNE? So the SPNE, remember, is a subgame perfect Nash equilibrium. A Nash equilibrium is a specification of strategies for each person. Right? What is a person's strategy? It's a specification of what to do at all of a person's nodes. So, for example, the boyfriend's strategy is this, 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 and this. The girlfriend's strategy is this, this, and this. It's that combination of nodes, of choices. So when I color in all these arrows, that is the subgame perfect Nash equilibrium, the specification of those arrows. So you can simply say SPNE is this by coloring the arrows.
Oh, okay.
So this is the outcome at the end, right? But what would not be correct is if I said this is the SPNE and not colored in anything else.
Okay,
You
because
see?
they're on SPNE.
Yeah, exactly.
Okay.
To understand why this happens, I have to specify why the person chose here, which depends on all these other choices up here.
And you started at the end always?
For backward induction, you mean?
Backward
Right,
induction.
exactly, yeah. So for backward induction, you always start in the end because, in some sense, kind of like I was saying before, right? What, for example, in this case, the centipede, what one does here depends on what everything else happens here, right? So you can't really tell what one's going to do before figuring out what happens here. What you can do is figure out at the very end, right? Because at this point, 2's choice doesn't depend on anyone else, right? So to start the end, 2 is going to choose, I guess, like 16, right? It's going to choose down. Once you have that, then you can figure out what 1 does here.
Okay.
So that's why you start at the end, because those are the easy ones. And then once you have that, you work your way backwards, so to speak.
Okay. Can you have a negative probability?
No.
No.
If you have a
Okay,
negative
I'll double
probability,
check.
it's exactly. Is that the Gao-Nash one?
Yeah, it's okay. It's probably just math. I think I understand it.
Okay. Yeah, you shouldn't get a negative probability. The only way you get negative probability is like there's domination or something weird going on.
Okay.
Right.
Okay. So on this, when you have multiple nodes for both players,
Right.
the chart is like.
Yeah, this is great.
Right?
So this means person 1 chooses A in this node, and I guess this is what 1 chooses at the first node, and this is what he chooses at node 3, so to speak. And then this one, that's fine. This is great. Yeah.
Oh, okay.
Yeah.
So how would we fill that out? 1A,
Mm-hmm.
and then
Mm-hmm.
3A.
Okay, so yeah, what happens, for example, here? Well, 1 goes A first, right? Then what happens here? 2 does what?
2A.
Right. Then 3 does, not 3, but at this node, third node. Then
And 4A.
Yeah.
So it would be 8A.
yeah, exactly. How about here?
1A. So you go from 1A to 2A.
Yep.
Okay. 1A, 2A, 3A, 4D. So
Mhm.
it's just 1A, 2D, and it ends here.
Yep.
1A, 3, 1A, 2D. So it ends here again.
Mm.
And you just ignore whatever comes after because
Exactly.
they didn't
Yeah, exactly right.
1A, 2A, 3D,
Mhm.
4, 4.
Mm-hmm.
2A, 3D again.
Hold on. It's 1A, 2A, 3D. Yeah, okay. Right.
1A, 2D. 1A, 2D. One D, so it's just 2, 2.
Mm-hmm.
So the 2, 2 for
Yes,
everything?
absolutely. Mm-hmm.
1 D, so again?
Mm-hmm. Right.
Okay. And then we do the elimination.
Right, exactly.
Okay.
Right. Okay.
Okay, that's good.
That's good.
Yeah.
Great.
Yeah,
Okay.
that's better.
Okay. Okay.
Okay.